If you're planning a deck build in Calgary and you've started collecting quotes, you've probably noticed a common pattern. Reputable builders are giving you two distinct foundation options. The first is the traditional method, concrete footings. This requires digging deep below the frost line and pouring concrete to create a solid base. To survive in Alberta winter, that traditional footing needs to be substantial. Take a look at this diagram. You're looking at a 12-inch diameter sonotube, and notice how it extends down to a flared bottom deep below grade. Then there's the modern alternative, helical piles. These heavy-duty, engineered steel shafts get driven into the earth like massive screws. Look at the left side of this diagram, showing a helical pipe pile. Instead of digging a hole, those welded plates pull the shaft deep into the soil layers until it hits the necessary torque resistance. Here is the reality. Both of these methods are fully structurally sound. They are well regulated, and they both meet Alberta's rigorous building codes. This brings us to the biggest assumption people make, that one is vastly cheaper than the other. When you price a standard residential deck honestly, the total costs usually land within 5 to 10% of each other. Because budget is essentially a tie, your decision actually comes down to your site's access, your yard's specific geology, and your tolerance for yard damage. Even though the final price tag is almost identical, the way your money is spent looks completely different. This chart shows how a concrete foundation budget breaks down. You're paying heavily for the materials and the extensive labor required to dig and form the holes, with very little going towards specialized equipment. That labor cost covers a grueling process: a crew digging by hand or auger, building the forms, pouring the mix, and then waiting days for everything to cure before they can even start framing. Now look at the second column for helical piles. The final height is exactly the same, but the composition changes entirely. Your budget here goes almost entirely to the steel piles themselves and the specialized machinery required to install them, leaving very small sections for labor and materials. That shift in spending translates directly into speed. A machine drives those piles to the required torque resistance in just a few hours. The second the machine is done, your builder can start laying the frame. If you have a tight timeline, that is an immediate return on your investment. You are skipping days of waiting and compressing the entire foundation phase into a single afternoon. Time isn't the only variable. We have to look at what actually happens to your property during the installation. Pouring concrete is inherently messy. It means excavators in your yard, deep auger holes, mounds of displaced dirt, and wet concrete to manage. Getting all that material into your backyard requires heavy wheelbarrow traffic. If you have mature gardens, astroturf, or an interlock pathway, a concrete install can easily ruin it. Helical piles eliminate that collateral damage. The installation relies on a compact tracked machine that drives the steel directly into the lawn. These machines are small enough to squeeze straight through a standard backyard gate and maneuver down tight side yards without an issue. When the job is done, there is absolutely zero soil displacement, no curing mess, and your lawn remains untouched. For properties with significant landscaping, helical piles preserve the yard where traditional excavation would require a complete restoration. There is an invisible, long-term threat you have to account for in Alberta, and that is our extreme freeze-thaw cycle. Temperatures here regularly swing from -30 to +30 Celsius. Those massive temperature swings cause frost heave, meaning the soil expands and contracts with immense force as it freezes and thaws. This animation shows exactly what happens underground. As the soil freezes and expands, it grips the rigid sides of a concrete column and pushes it directly upward. While a code-compliant footing is designed to sit below the frost, it remains a static object in a moving environment, and years of pressure can lead to leveling issues. Watch what happens when we swap that concrete out for a helical pile. The shaft and its welded plates are designed to move naturally alongside those expanding soil layers. Instead of fighting the upward force, this engineered design allows the pile to flex and follow the ground's natural cycle. In a 20-year cycle of Alberta winters, this ability to move with the earth provides a consistent level that static concrete columns are not designed to match. Despite those advantages, traditional concrete is far from obsolete. It acts as a critical fallback for specific, challenging site conditions. The primary geological roadblock for a helical pile is hitting shallow bedrock or a highly dense, impenetrable layer of gravel. If a steel pile physically cannot penetrate the earth to reach the required torque, excavation and concrete become mandatory. The second exception comes down to sheer weight. Looking at this blueprint of an elevated deck cantilevered over a walkout basement, you can see the intense structural loads involved. Massive features like that, or a heavy timber pergola, require a much wider foundation footprint to safely distribute the weight. That engineering reality frequently favors concrete. Also, if you're building on a rural acreage property with wide open access and raw dirt, the cleanliness of a compact machine doesn't matter as much, bringing the choice back to a true tie. Concrete footings shouldn't be viewed as an outdated standard. They are a specialized, heavy-duty solution reserved for extreme geological and structural challenges. Both of these systems are legitimate engineering solutions, but they serve entirely different residential scenarios. This matrix evaluates your property. The bottom axis tracks access. The side tracks geology. For tight access, finished yards, and standard soil, helical piles are the definitive recommendation. For open access, heavy loads, or bedrock, concrete footings are your necessary tool. The most critical takeaway here is to stop letting a negligible 5 to 10% price variance paralyze your decision. Instead of looking at your wallet, go outside and evaluate your gate width, your existing lawn, and your local soil composition. The optimal foundation is never determined by a blanket preference or a price tag. It comes down to matching the specific engineering advantages of the system to the unique physical realities of your backyard.